Hi, I'm Doug Black. I'm editor-in-chief of Inside HPC. And today we're talking with Alan Benjamin. He's CEO of GigaIO. And Alan's going to talk about a new GigaIO solution that addresses composable disaggregation infrastructure. And this is brought on by combinations of CPUs, GPUs, other accelerators, also with the explosive growth in data used in various high-demand workloads, including machine learning and high performance data analytics, all of which drags down systems performance and results really in wasted compute resources. So, Alan, it's great to be with you today. Please go ahead.
Well, thank you, Doug. And I am tremendously excited to be able to share some of the things that we are working on here at GigaIO. And so let's just jump right into it. And we start with the changes that are taking place in the data center because they are quite enormous now. And we'll start up here at the top. Whether or not it's the end of Moore's law or the slowing of Moore's law doesn't really matter. And it's now about the incorporation of GPUs and other kinds of accelerators into that work stream. And lots of people talk about the explosive growth in data. So I won't spend too much time, but from our perspective, the interesting part has been this growth in data has really led to a blossoming of artificial intelligence. And the artificial intelligence is driving really quite a variety now of machine learning kinds of pipelines. And so the variation in these workloads has increased quite dramatically. And when you combine that together with distributed computing and with microservices, it's driving a transition to what we call workflow-centric architectures. And we will talk about that later. And then to cap it all off, of course, there's a movement to move a chunk of this capability out of the data center and move it out to the edge, close to where all this data is being generated in the first place. So particularly in the HPC community, yesterday was really about homogeneous computing. And it was about combining tens or hundreds or even thousands of servers together to be able to complete the computations. And all these servers were linked together using MPI. And today, NVIDIA is doing a tremendously good job in helping these application companies take the computationally intensive portions of their code and move them to GPUs. And so we would call this a limited heterogeneous compute. And you'll see why later, where we think it moves. But quite literally, the usage of the GPUs is now exploding. And NVIDIA will publishes dramatic numbers in terms of the performance gains that can be achieved by moving the computation out to GPUs. And they now publish, I think they say that over 650 applications now support the use of GPUs. The issue is that the rack architecture that holds all of this is now more than 2 decades old. And so you take the fundamental building blocks of the server. So we take the processors and the memory and now the accelerators and the storage, and they go into fixed configuration servers. And inside that server, bandwidths are moving up with PCI Gen 4 to 256 gig. The latencies are good. And you take those servers and you stick them inside of a rack and you attempt to communicate between them. And your bandwidth is fine, but you run into latency problems because Ethernet and InfiniBand, the latencies are going to be much higher. And the performance is non-deterministic. And the result is very predictable, right? There's a tremendous amount of waste of these resources that are sitting in the data centers. This quote comes from Intel, and it's interesting to us in the last 120 days, we've seen and heard almost the identical quote from people like Dell and IDC and Inspur and the Next Platform and Forrester Research. And from our customer conversations and our channel partner conversations, these numbers don't surprise anyone, right? Everybody sees, this sort of usage. So the key is to be able to disaggregate. The key to eliminating the waste is to be able to disaggregate, which is in theory, take those resources out of the servers and create their own separate pools. The problem with this is if you connect these pools together with a traditional network, is you get killed in performance. And so, really articulated well by some of the architects over at Google Cloud. And of course, I wouldn't show this slide if I couldn't show you this one, right? Which says now with Fabrics, you can now compose across Fabrics with absolutely no performance penalty. So this is an example we've run here. We have a standard converged server. We put 1, 2, 4 GPUs. We run standard ResNet testing. And then we take those same GPUs, we compose them across a Fabrics network, and you can see you get the same numbers. And interestingly, you can even get a boost. So you not only don't pay a penalty, you can actually get quite a bit of gain as a result of composing. And oh, by the way, you can compose more than 8. And how do we do it? Well, so at a network level, if you're trying to communicate, let's say from server number 1 to server number 2, the output of that processor in server 1, whether it's AMD or whether it's Intel or whether it's ARM or IBM Power, the output of that processor is PCI Express. And the internal architecture of those servers is PCI Express. And today, if you're communicating, let's say with Ethernet, you plug an adapter card in, you convert from PCI into Ethernet, you go across the Ethernet network into the next server, where the first thing you do is convert it right back to PCI Express. And so plain and simple, the heart of our network is we have figured out how to make PCI Express into a true network. And so we never make the conversions anywhere in the network. And so our latencies are quite good, right? We're well below a microsecond. And of course, depends upon the software you stick on top of it. And we're the only pure PCI network that can connect both resources and servers on the same network. The advantage is, this is an example of an output from a total cost of ownership tool that we have created that enables customers to put in their own use case. And so they can talk about the number of servers they want to use and the number of GPUs and the number of work groups that they're supporting. And we've created this tool together with a number of our customers and our channel partners. The results are dramatic. And so here's an output of an actual run. And you can see building a system across Fabrics and building a system across InfiniBand. You get practically the same if you're building it across Ethernet. And you can see it is building with Fabrics, your CapEx costs are dramatically different. Your OpEx costs are dramatically different, and your power usage is dramatically different. So if you can disaggregate and recompose, you can fundamentally look at your system in a different way, and your savings can be quite dramatic. Now, it should be fairly obvious that once you open that box, and now you start to move certain parts, in this case, the computationally intensive parts have moved off to the GPU, then other parts of that code are going to start to move as well. And we're seeing lots of our customers now that, they've got V100, so let's say for their computation part, and now they want Quadros to do visualization. So they want both. And maybe they're bringing AI into their work stream, and so they want inferencing, capability, and they want training capability. And then they want to move some of their data flow into FPGAs. And so this leads to where we believe is a workflow-centric architecture. And you combine this together with microservices architectures and distributed systems that are running in the servers. And, it is Fabrics's breakthrough latency capability and our ability to run DMA throughout the network that now revolutionizes the efficiency of this data movement. And so we call this cloud class composition. And it's the ability not only to compose elements onto a server, but it is the ability to combine that with the ability to talk server to server or to have internode communications that really enables an effective rack scale composition. So in order to minimize your TCO and to improve your serviceability, you want to disaggregate and you're going to want to run server composition. But you need the internode, whether it's NVMe OF or GPU Direct RDMA, which are really, you can think of as composition protocols that are running in a network environment, or it's traditional inter-server communication, things like MPI and TCP, which we can run all of this across one PCI network, so we can deliver scale and easy integration. And that's what enables us to say we can deliver any server, any device, anytime. And there are people that, there are people that can do server composition part, and there are other people who can do internode communication part. But we're the only people that can do both at the same time, running across the same PCI network. Now, for us, it's always been about being an open platform. And, whether it's the hardware perspective, software, or the management side, in the hardware, the fact that we're a standard PCI network is tremendously advantageous. So just about any endpoint device that you can think of supports PCI. All of the accelerators, all of the storage devices, all of the network adapter cards, all of the persistent memory vendors, they all support PCI Express. And so we have to do very little work for people to be able to use their hardware in our system. It just works. And we've plugged in hundreds of devices and it just works, right? It's fascinating to watch. On the software side, Linux capability, of course. We have customers that are using Windows and composing with no issue. Because of where we run on the network, any container, any orchestrator, any VM, all the storage, all the big data frameworks, all those things all just run on top. And we're really focused on this bottom area about working with the leading composition and orchestration software packages to enable them to be able to not only orchestrate and compose at the server level, which they have been doing for some time, but now they can reach inside and in the same software platform, they can compose resources to match the data stream. So we'll talk about this in a second. On the fabric management side, we support it it's a full range. There are people that want to work at the command line level. If you're used to using Chef or Puppet, this is an easy place to go, all the way up through very standard Redfish APIs for industry compatibility. Now on the ready to run, we're working together, and these are a couple of examples of the companies now that are certified ready to run with us. And so these are enterprise class software with all of the security measures and access controls and provisioning capability and policy driven compliance. This is all the stuff that you expect to have at an enterprise level. And now for the first time, these two packages can reach inside and they can compose resources on the fly. And, so for example, if you're used to working in a Slurm environment, which most people in HPC are, Bscaler, for example, can now interpret that Slurm stream and can reach inside and compose the infrastructure necessary to run that job. So it no longer has to fit it on a best case basis to a fixed infrastructure. Now, no presentation of ours would be complete without talking about really the incredible resurgence of PCI Express. And, we show on the chart, Gen 1, Gen 2, Gen 3 PCI was clicking along, and there's a long gap between Gen 3 and Gen 4. And that was a painful gap. And the industry felt that. And, there were some questions as to whether, PCI would continue. And in very short order, the PCI SIG has really done a tremendous job. PCI 4 is now out and shipping. Gen 5 the standard is complete. Plenty of vendors are working on Gen 5, and we'll see these solutions now in the next year or two. PCI Gen 6, the standard is well under development. I think it's sitting at a 0.7 release, and it will get done here in short order. So the performance map to a terabit per second is in our very near future. And recently there's an announcement around CXL, and CXL will be a new protocol that will run on top of the PCI physical, and it will bring cache coherency and other sorts of features. We're very active in CXL, and we're part of that committee. And as Intel would say, for the first time ever, every processor vendor is on board with the same cache coherency protocol. And so we work across all PCI generations. We're currently shipping PCI Gen 4. And of course, we'll extend that into CXL. So, Doug, that's our story. We're tremendously excited about it. We've seen some really startling good results at customers, and we'd love to be able to demonstrate that to folks. We've included an email and location to be able to do that, and we welcome being able to share this with folks.
All right, Alan. Well, great stuff. So just to clarify, you're doing server composition and internode communications, and no one else does both of these at the same time? Nobody else is addressing both issues simultaneously? Do I have that right?
Correct. Exactly. So there are companies that can compose resources to servers, and there are other companies that, obviously Ethernet or InfiniBand, can do internode communication. There's nobody that can combine the two together on the same network across PCI, enjoy the latency and bandwidth advantages of PCI, and the ability to have DMA transactions, not RDMA. And so we can eliminate the bounce buffers throughout the system and enable resources in one part of the infrastructure to directly DMA, because it is PCI Express end-to-end to other servers. And we're the only folks that can pull that off.
All right, great. Well, of all the variety of technologies that are incorporated in HPC, that I think the fabrics are one of the most fascinating for me. It borders on magic, I would say. So I might be signing up for a demo.
Great. We'd love to show you the magic.
All right, real good. All right, Alan. Well, thanks so much for spending time with us today.
Well, thank you for having us, Doug.
Great.